We're continuing with the back page of 5.6 derivatives of inverse trig function notes. So looking at example 3 here, write the expression of secant of arctangent of 3x in algebraic form. So first we focus on what's inside the bracket to identify the side lengths of our right triangle. So theta, I'm going to just assign that to be theta. Arctangent of 3x, another way of thinking about this is tangent of what angle is equal to 3x. So tangent of theta is equal to 3x. So 3x is the same thing as 3x over 1. We know the ratio for tangent is the relationship is opposite over adjacent. So I'll let the opposite be 3x. I'll let the adjacent be 1. Now we can figure out the missing hypotenuse by going to Pythagorean theorem. A squared plus b squared equals c squared. And then take the square root of the sum of the two legs there squared. So 1 plus 3x squared, which is 9x squared, to take the square root, and that will be the hypotenuse. Once we have this information, then we can figure out secant of theta. So secant of theta is simply going to be adjacent over hypotenuse. I'm sorry, hypotenuse over adjacent. Secant is going to be the reciprocal of cosine. So hypotenuse over adjacent. So square root of 1 plus 9x squared all over 1, which is square root of 1 plus 9x squared. All right, moving on to the derivative now. There's two ways that we can do this. The first way is using implicit differentiation. So go through that way first, and then we can step through the derivatives using the derivative rule, which is a lot faster, but it also requires more memorization on the student's part. All right, so one way that we can find the derivative arc sine of x here is we can take the sine of both sides, and then we can use these inverse properties to help us through the problem. So if I take the sine of both sides, the sine of y is equal to sine of arc sine of x, and then sine of arc sine of x, we know that we know this property is simply just going to reduce to just be x. So now we've rewritten the equation as sine of y is equal to x. Second step, we find the derivative implicitly. So the derivative for sine of y becomes cosine. Also, we have to use implicit differentiation since now the y is no longer by itself. We have a y that's within an equation. So to find the derivative where the y is not set apart by itself, we have to go through implicit. So the derivative for sine of y is cosine of y times y prime, or cosine of y times dy dx. And then the derivative for x becomes 1. Okay, so next step, solve for dy dx. So solve for dy dx, we can divide both sides by cosine of y. So dy dx equals to cosine of y, which in other words is secant of y. So we essentially found the derivative. We just have to get this expression in terms of x. So secant of y, now we know what y is in terms of x, right? We know y, going back to the original equation, is arc sine of x. So dy dx equals secant of arc sine of x. So now this becomes like a problem that we saw with example 3. We're just trying to figure out an expression for this. So again, we start off with a right triangle. We can draw a right triangle here. Another way of thinking about this is sine of theta is equal to x over 1. So sine of theta is equal to x over 1. Sine is opposite over hypotenuse. Once we have these two values, we can go through Pythagorean theorem to find the missing leg, which is the square root of 1 minus x squared. Now we want to find the secant of theta. So secant of theta is going to be the reciprocal of cosine, which will be hypotenuse over adjacent. So 1 over square root of 1 minus x squared. So therefore, that's what dy dx is. 1 over square root of 1 minus x squared. Okay, number 6, find y prime for y is equal to arctangent of 4x. We're going to go through implicit first, and then I can step through using the rule. So, going back to example 4, we can simply also use the rule for arc sine of x if we just go through the rule here. So the rule for arc sine of x is u prime over square root of 1 minus u squared. So u prime, the derivative, our u is going to be x, so the derivative for x is going to be 1. All over square root of 1 minus u squared, our u is x, so 1 minus x squared. So 1 over square root of 1 minus x squared. So as you can see, The rule is a lot faster to get to the rule to get to the derivative to our answer, but implicit is a little bit it requires more steps, but requires less things to memorize. All right, example 5, find y prime for y is equal to arctangent 4x. I'll go through implicit first. So first step, we're going to take whatever the trig function of both sides is to undo the arctangent. So in this case, we'll take the tangent of both sides. Tangent of y is equal to tangent of arctangent of 4x. We know tangent of arctangent is going to be reduced to be just whatever this expression is. So tangent of y is equal to 4x. Now we can differentiate implicitly. So tangent of y, the derivative for tangent of y is secant squared of y times y prime, and then we represent y prime as dy dx. 4x goes to 4. Solve for dy dx, and we get 4 over secant squared of y. Bring the secant squared up as cosine squared y. Replace y in terms of x, so y gets replaced with arctangent of 4x. Now this becomes 4 cosine squared of arctangent of 4x. Let's figure out what arctangent of 4x is on the right triangle. So if we have theta, arctangent of 4x, same thing as tangent of theta is equal to 4x over 1. So 4x over 1 is opposite over adjacent. So opposite over adjacent, we can figure out Pythagorean theorem, what the hypotenuse is. In this case, square root of 1 plus 16x squared. So now we're replacing this expression with cosine of theta, right? Cosine of theta is going to be 1 over square root of 1 plus x squared. However, the cosine is being squared, so we have to represent the ratio as parentheses squared. Now once we have that as parentheses squared, then we can square everything inside the parentheses, and we get 4 times 1 over 1 plus 16x squared, and then we can write it as one fraction, 4 over 1 plus 16x squared. Now if we want to use the derivative rule for arctangent, we know looking at the top here, the rule for arctangent of u is u prime over 1 plus u squared. So if we step through the rule, first off is u prime. So u prime, our u value is 4x. So the derivative for 4x becomes 4. So that goes in the numerator. And the denominator is 1 plus u squared. So 1 plus, our u value is 4x. So 1 plus 4x quantity squared, which becomes 16x squared. And then that matches with the steps that we just took using implicit. All right, example 6. Find y prime for 2 arcsecant of 3x squared. I'm just going to go through using the derivative rule. So 2 is a coefficient that just kind of stays out here. Arcsecant of 3x squared. 3x squared is my u value. So we can simply use our rule for arcsecant, which is going to be u prime over absolute value of u times square root of u squared minus 1. So u prime is the derivative of 3x squared, which becomes 6x. And then the denominator is absolute value of u. So absolute value of u is just going to be absolute value of 3x squared times the square root of, now the u and the u's sit next to each other, one outside and one inside the square root. So square root of u squared minus 1. So we replace u with 3x squared, quantity squared, don't forget that. So then that becomes 9x to the 4th minus 1. The 3x squared, the 3 will cancel out with the 6, and the x will also cancel out as well, leaving us with just an x in the denominator. So 4 over absolute value of x, square root of 9x to the 4th minus 1. Okay, example 7 here. Find y prime for y is equal to x times arc cosine of 2x. Now, arc cosine of 2x, we can use the rule for arc cosine of u, which is just the negative version of arc sine, right? Negative u prime over square root of 1 minus u squared. However, notice that there's another variable that is in front of the arc cosine of 2x. So we just can't use power. We can't just apply the rule directly for arc cosine of 2x. We have to think of these as two separate expressions or two separate variables, two separate functions that are related to one another by multiplication. So that means we have to go through product rule to find the derivative. So product rule is f prime g plus fg prime. So f prime, the derivative for x is 1. The derivative for cosine, arc cosine of 2x is just going to be, f prime g. So f prime is 1, and then we take the original g function, plus f, which is x, and then g prime. So the derivative for cosine of 2x is negative u prime, so negative 2 over the square root of 1 minus u squared, so square root of 1 minus 2 quantity squared. And if we simplify this a little further, we get negative 2x over square root of 1 minus 4x squared. Okay, example 8, we want to find the derivative for cosine of arctangent of x. Now notice that we can go through this using chain rule here, cosine of arctangent of x. So to do that, we can think of this as a derivative of cosine and then multiply by the inside function's derivative. So the derivative for cosine of u is negative sine of u times u prime, and the derivative for arctangent of x is going to be 1 over 1 plus x squared. Okay. And if we have that, then we can simplify further here. Sine of arctangent of x, we can clean this up a little bit more, because arctangent of x, if we write it in terms of a triangle here, tangent of x is going to be theta here. So arctangent of x is the same thing as saying tangent of theta is equal to x over 1. So opposite over adjacent. We can go through hypotenuse. To find hypotenuse, we can go through Pythagorean theorem. So square root of 1 plus x squared. Now the sine of theta is just going to be opposite over hypotenuse. So x over square root of 1 plus x squared. And we can combine this a bit more to make it negative x over 1 plus x squared raised to the 3/2.